Okay, class. Tonight we are going to continue with our third chapter, that will be statistical inference. So what we are going to do tonight would be basically how we can use our sample to make a conclusion about your population. Remember last time in chapter 1, we did discuss about if we have our population, okay, due to some reason, for example, limited of time, limited of money, limited resources, for example, our manpower and so on and so forth. So what happened is that instead of collecting all our subject in our population, we are going to choose subset of our population and we name that as our sample. Okay, so what happened? We collect our data from our sample where we choose our sample using random method, random procedure. So there will be quite few method of random. So I'm not going to talk about that because it is not covered in your syllabus. So what happened is that we are going to measure the things that we need to what we call collect from our sample. Now, from our sample, so in chapter 1 last time, okay, in chapter 1, what we do, we collect our sample and we measure them. If let's say our x that we are interested in is our length, okay, we are going to select all the length of our n. For example, our n is let's say 100. So we measure 100 subject and find the length. Now, in chapter 1, what happened is that when we have our data, so for example, we have x1, x2 until your 100th x. So you have 100 measurement. So you're going to discuss on how you can what we call transform this particular data into meaningful information. So we have the first one, what we call graphical. Okay, graphical representation, and we may also use our what we call numerical presentation. Okay, and a part of that, what we can do is that we are going to look how this data can be what we call investigated using measure of central tendency, that is the mean, mode, and median. And we do also study on how it can be distributed. Okay, so we do the measure of dispersion. So we know, we can see how much our data, that is our x, will be distributed. Okay, so that will be measure of dispersion. And when we talk about measure of central tendency, our focus will be at the middle of our data set. Now, having said that, we move to chapter 2. Okay, in chapter 2, what we do is that, okay, knowing we are still talking about our x. Okay, in chapter 2, we still talk our x, but now this what we call random variable. So in chapter 1, we call it as variable. Okay. But in chapter 2, since we are talking about specific x that we have investigated, so we call this as random variable because we know that those measurements that we collect will follow certain probability. Okay, so random variable. So in chapter 2, what we do is that we investigate how this x is distributed. Okay, for example, if you can still remember, so what we do is that we are going to see how this x, if it follow binomial. Okay, and we can see if it is following binomial, how we can find the probability of x equal to or less than or greater than or whatsoever things that you are looking for. It is what is the probability of that particular x random variable. Let's say it equal to certain value of x. And if we have another discrete probability distribution, what we call Poisson, And we know that for Poisson, we also can find the probability of X if it is following Poisson. And of course, you have your formula on how to find your probability of X if your X is following binomial or if it is following Poisson. Okay, so a part of that, the last part of chapter 2, we see how we can if our random variable X is following what we call normal probability distribution, where the parameter involved would be mean, mu, and variance sigma squared. And we know that for this particular continuous random variable, it will be somewhat different as what we have covered in discrete probability distribution. Now, what we do then, we know that our this probability, since if we repeat the binomial probability distribution, if we repeat the experiment further and further, whereby the number of trials become larger, we know that it can be approximated to one another. For example, we can approximate our binomial into Poisson following certain conditions. And this also can be done to normal probability distribution. So I wish to what we call simplify the gist of what we have covered so far in chapter 1 and chapter 2. Now, what you have covered in chapter 1 and chapter 2 is not yet covering what we call the statistical inference that we need to study. Okay, statistical inference is your what we call stepping stone if you wish to do investigation further for your experiment. So statistical inference is somewhat like the door for you to go to chapter 4, okay, and chapter 5. Okay, so if you understood chapter 3, then chapter 4 and chapter 5 will be much easier because in chapter 4, we are doing statistical inference as well as in chapter 5. So if you look at your textbook, okay, on page 73, okay, so please, when we put your topic in certain chapter outline, so this is somewhat like a summary of what are the things that you need to cover. So please look into detail what you can have under the chapter outline. So basically, okay, we are going to cover some introduction, sampling distribution. So sampling distribution is the fundamental understanding of how statistical inference is all about actually. Now, when we talk about 3.3, we start discussing how we can make statistical inference using our sample, okay, measuring all the sample value and everything, and from the sample that we have collected, how we can make what we call generalization or conclusion for our population. For example, if we are talking about the mean of our sample, and we are going to use this mean of our sample, how we can interpret our mu of our population. Okay, so that would be as simple as what I can see about statistical inference. And for example, for the statistical inference, we can divide them into single population, means that you have only one population, or you can have two population. So you have 3.3, one population, 3.4, two population. Okay, so there will be somewhat similar actually, but then the difference is just when we dealing with two population, if we are talking about X here, so if two populations, so we have x1 minus x2. Okay, so that will be on how we deal with the two populations. We are going to look into further afterwards. Okay, and if let's say we may have what we call normal probability distribution, whereby our random variable is following the normal distribution. Somewhere in the experiment, you will have your data is not following the normal distribution. So if that happen, how we can tackle that variable. So we have another option versus the normal probability distribution is what we call non-parametric statistic. Okay, so if we have one population and two population, so we have two options for our non-parametric where we know our data is not following normal. So for one population, we call them as sign test. So this is one population. And for Whitney test, we are dealing with two population where our data here is not normal. It could be this way, it could be skewed to the left, or it could be uniform or whatsoever. Okay, but of course, this part is for data that is following normal, and this part is not normal data. Okay, not normal data. So far, okay, everyone? Can you follow? Can you follow, class?
I can, I can.
Okay, okay.
Okay, thank you. Now, okay, thank you. So if you look at the bottom of your chapter outline, there is learning objective written for you. Okay, so these are the basic what we call understanding that we wish every student can understand. When I say understand, it's just not you understand, but you know how to do you using your hand on how you can solve the problem involving the things that we have discussed just now. Okay, so please read what are these under the learning objective. Now, let us go to the introduction of our statistical inference. So I believe you can have that particular figure in your textbook on page 75. Okay, so please look at your page 75. I'm not going to like last time I go up one paragraph after one paragraph after one another. So for this chapter 3, I'm going to skip some part of the what we call paragraph. So those the one that I skip, I wish everyone can read it on your own and try to understand how it contribute to your understanding of your chapter 3. Now, in simple way, what is statistical inference? Okay, so statistical inference, as I mentioned just now, we have our population. Okay, when we say we have our population, okay, ideally, if you want to do some research, you need to find your population data. Okay, but somehow we know that we don't have money, we don't have what we call enough time, so we are going to collect our sample in such a way that our sample will represent our population. So that's why the way we collect our sample will be random. Okay, random. What do we mean by random? It means that if I have 1,000 subject here, if I'm choosing one subject here, the probability of choosing here is equally likely. So it will be 1 over 1,000. If let's say your population is 1,000. So the way we choose them is equally likely to be chosen. Now, let's say we have collected our sample. Okay, so from our population, we collect our sample. And from our sample, we are going to measure the things that we need to investigate. If it is involving height, weight, length, or whatsoever things that you are investigating. So we are going to measure them and collect them into a data set for you to investigate further. Now, remember last time when we talk about sample, we can have our what we call statistic, sample statistic. Okay, I take this. Okay, so our sample statistic, if we are talking about mean, it will be X bar. If it is proportion, okay, it will be P. Okay, our parameter, if we are talking about mean, we are talking about mu. If we are talking about proportion, we are talking about P, capital P. So we are going to use this a lot afterwards for our discussion. Okay, now how does this mu and X bar related? Since we are collecting our sample, and we collect our sample, and our sample is the list of X from your N first until, let's say this is your observation number from 1 until your N value. So you will have your data. Okay? Add all together, divide by the number of samples, you get the mean. We are going to discuss further how this sample mean is actually the sample population. So the way we prove that this X bar is actually representation of your mean of your population. So that one will be discussed in chapter 3. Okay, so it will involve few procedure involving what we call point estimation or interval estimation, as well as what we call hypothesis testing afterwards. Okay, so I hope by now when we know that when we have our X bar, we are going to make inference for our population mean. That will be mu. So what happened to mine? Okay. That's why our mu here will be used to draw a conclusion for our population. So this is how the whole what we call diagram here supposed to mean still. Okay. Any questions so far, class? If no question, I go straightforward. Okay. Now, talking about statistical inference. So if you look at your figure 3.3, okay, so I believe this is under figure 3.3. So I take this from the internet just to give you another perspective of how this statistical inference is all about. Okay. When we say statistical inference, okay, we are trying to make inference for our population using our sample. So how can we do that? We have two options. First, we are using the parameter estimation. Why parameter estimation, class here? Remember, parameter estimation, we are talking about mu, we are talking about proportion. Let's say we just narrow down into two only. So there will be more others other than mu and proportion, mean and proportion. But somehow, let's say we have in mind, we are talking about parameter estimation involving mu and involving proportion. Now, how we can do that? We can use point estimation or we can use interval estimation. Okay, so interval estimation, it will be involving the mean and involving the proportion. Okay, so that would be parameter estimation. What about hypothesis testing? So this one is further away with more understanding that require you to what we call to make your statistical inference. So this one is what we call a bit complicated, but most of the time, if you're talking about experiment, this one will be used as your proof. As your proof that your experiment is actually representing your population, or you can say your experiment is giving you a proof of your sample that that can be used to what we call make inference for your population. Okay, so that would be in simple way how the statistical inference can be done. Now, if you turn to page, if I'm not mistaken, yes, page 75. Okay, 3.2 sampling distribution. What does this sampling distribution has to do with your statistical inference? Okay, now please what we call assume this oval as what we call our population, our one population. Now, by using our population, you can sample out different samples from the same population several times. Okay, if I redraw again, let's say I have my population here. Okay, now usually we only take one sample. Okay, we choose our sample random so that our selected sample is representation of our population. So let's say I assume that this is my first sample. I sampled for the first time. Okay, so this is sample 1. Okay, and from this sample, I can investigate what would be the mean or what would be the sample proportion. Okay, I can repeat again for the second sample, S2. And I collect the data, I measure the data, and then I make some what we call calculation, and I get my second sample from my second sample. Okay, and I have my S2. And I can repeat this again and again. Let's say I repeat until my 100th sample. Okay, I repeat until my 100th sample. And from here, I can measure my X bar 100. And I can also, let's say, if we are investigating the proportion, I can have my proportion of my 100 sample. Now, what happened here when you repeat again and again? So when we repeat this sample, this is what we call sampling distribution. Why? Because from this particular first sample, this X, if let's say assuming that this X is following normal, so this X1 is normally distributed with mean mu and variance sigma squared. Okay, remember our sample is representing our population, so we use this as our representation of our sample. And this particular thing the same will have the second of distribution until your X100 is following, let's say all of them are normal. Okay, now when you do that, actually those samples that you have done, you can imagine as this, following this. Okay, this arrow. Now when you repeat your sample again and again, what happens is that you will find your sample will be distributed close to one another. For example, if I can put this as, let's say this is sample 1, this is as sample 2, this is sample 3. Let's say this is our 100 sample. If you can have that plot for you, it will be near to each other. Okay, and of course there will be different mean value for our sample. For example, mean for our first sample is this one. For the second sample is this one. For the third sample, this one. Okay, imagine that way. So now, statistician has proved. Okay, when you do your resampling again and again, what happens is that your mean samples is actually under the population mean. And if you can imagine, the population mean will be the larger distribution here. So this one is your population mean. Okay, so that's why if you look on your textbook on page 76, so please look at page 76, sampling distribution of sample means and sample proportion and relationship between population distribution and sampling distribution are related to this particular understanding. Okay, so please read 76 and it reflects this particular understanding. Okay, so having said that, okay, statistician come up with procedure. Okay, when you do sampling, if you wish to do the statistical inference, what happens is that you are going to collect your data once only. Okay, you are not going to do for several samples, knowing that it follow this particular understanding. Okay, so your sample that you do could be this one. Okay, Others do could be this one. So what we do, only one. But having in mind the understanding of sampling distribution will give you this understanding and the distribution of your X. Okay. Since we are talking about X bar, so this X bar is following normal with mean, mu, and variance sigma squared over n. So when you see this, so this is what we call representing your sampling distribution. But for now, please understand that this sampling distribution is your fundamental or basic understanding for statistical inference. Okay, now let's look at the first what we call parameter estimation that we can do if you wish to do that. And for this part, I jump through to subchapter 3.3 that will be on page 77. Okay, on page 77, so you have figure 3.6. Okay, so what you do have is that if you want to make estimation, okay, you can have point estimation or you can use interval estimation. Okay, so what if we talk about the point estimation and interval estimation? We look at this part first. Okay, so remember, this one will involve one population and two population. Those who just joined my class, I think I need to someone please if I forgot to share the link for the attendance, please share with your friend. Okay, so I just share the link. So sad, only 38 of you join my class. Okay, I'm not sure what happened to the rest of your 20, 22, 20 something students. Okay, now let us continue. Okay, now how we can do the point estimation. Now, what is point estimation? What is interval estimation? Okay, it's just as simple as if you are talking about the weight of your friends. Okay, let's say we are talking about weight of RK24. We have, like, for example, we have 62 students, and we are going to collect the weight of our class, and then we find the average of our weight. So point estimation, let's say weight, average weight. Okay, so X bar can be estimated using 1 point. Okay, for example, let's say the X bar is, let's say, 57.5. Okay, so this is a point estimation. A point estimate is a single value estimate of an unknown population parameter. So by using our sample mean, we are estimating our population mean. Okay, we are talking about population mean. So statistical inference for population mean. And you can also have your what we call interval estimate. Now, knowing that when we do estimation, if we are talking about one single point, we may not get the correct or the exact value. For example, if we are investigating the weight and we find that the average weight is 57.5, somehow the actual population mean will be, for example, let's say 58, okay, kg. So what happens is that sometimes we do prefer to use the interval estimate. Why? Because a part of using the point estimate, by using interval estimate, you are going to widen the value of your estimation. Okay, instead of talking about 57.5, whereby we know that our population what we call population mean will be a bit larger than what we have estimated. So by using the interval estimate, we are more confident that our estimation is right. So instead of having 1 point, for example, let's say the lowest point would be let's say 555. Let's say 6 minus 5 will be 52. Margin of error plus minus 5. Minus 5 plus 5. So we will have 52.5 and then it will be 62.5. So you are estimating your population mean between 52.5 until 62.5. And here you feel much safer because your population statistical inference given in certain interval. Okay, so the potential or the what we call the, you are more confident with this particular interval estimate. Okay, so that would be how the estimation can be done. Point estimate or interval estimate. Now, what are the things that you should know under what we call interval estimate? Okay, so just now I have mentioned about how confident we are with our interval estimate. Okay, what will be the level of confidence when we do the estimation? This confidence level has to do with your what we call interval estimate, and this can be found in your textbook on page this one is on page 78. Okay, so please read some of the things that I did not discuss yet. Now, when we talk about the confidence level, okay, so this confidence level will has to do with your probability value. Remember last time, alpha that we are talking about is the alpha is the probability value that remain in the tail of your normal distribution. Okay, so we are going to use the same exact what we call understanding of alpha in this particular interval estimate. Now, when we discuss this interval estimate in terms of the confidence level, that's why we call it as confidence interval estimate. Okay, and this confidence level usually, okay, the most common one will be either 90%, 95%, or 99%. Can we do other than that? 98% can. Can we do 93% can? But most common we use confidence level will be this three. Okay, will be this three. When we say 90%, what does this 90% mean? So please look at this diagram here. Okay, so if we are talking about 90% confidence level, okay, so what will be the interval involved in our estimation? So it will be between negative 1.65 until 1.65. Okay, so this will be the level. And how this negative 1.65 and 1.65 here is obtained? Okay, knowing that the whole population, the whole probability is 1, okay, 100. Okay, 100. Now, with certain confidence level, for example, if we are talking about 90%, okay, we are going to limit our interval to only 90%. So whereby this particular 90% will be in the middle here. So if we talk about 90%, what will be the rest of our interval? It remains at the tail of our distribution. So we have 5% here and another 5% here. So when we set 5% here, so we are talking about our alpha. So what is our alpha here? Is 0.05. is our alpha. The same goes here. Alpha is 0.05. When we say alpha is 0.05, so you refer to your upper tail table, alpha 0.05, 0.05, so you will get this, right? So 1.6449. So you can take the whole value and that will be your critical value of your 90% confidence level. So this is called as critical value. Okay, critical value. Where is the critical value? Negative 1.6449 and 1.6449. Understood, class? Class, are you all okay?
Yes, doctor.
Okay.
Okay, okay.
Okay. So this is the basic understanding that you need to understand, because later on you are going to use this again and again. You can understand this easily, so everything will be easy for you. And we are going to use this critical value in our hypothesis testing. So if you understand here, then it will be easier later. Hypothesis testing. What about if we are talking about 95%? So if we are talking about 95%, then, okay, 95%. So the middle one is 0.95. So the rest of our 0.95, so that we will have 5% divided by 2. So you will have 0.025. Right. So 0.025 here and 0.025 here. So how? So we look at the upper tail table, 0.025. So we have 1.96. Knowing that the middle is 0, so lower than 0 is negative, larger than 0 is 1.96. Okay, so the critical value is 1.96. And the same if we are talking about 99%. Okay, even larger. So it should be larger. So if this is the right, what we call illustration. So you have larger. So if you look 99%, you have 1%. So 0.01 divided by 2, you will have 0.005. Right. So 0.005, 2.5758. That's why we get this 2.58 negative 2.58. So now, class, looking at this three diagram. So this diagram, the one that I put in green box, what can you observe from this, what we call confidence interval? Class, what can you observe? What can you observe? Look at the area shaded in red. What can you observe from the shaded area in red? Class?
Almost 100%.
What was that?
Almost 100%.
Almost 100%. Other opinion? Other opinion?
The area under is spread by bigger.
Okay. Almost almost correct. When you see, if you compare these three particular what we call diagram, what can you observe, class? Now, if you are talking about 90%, 95%, 99%, the alpha here is 10%, 5%, 1%, right? If our confidence level become larger, means that if we increase our confidence level, what happen? You will have larger CI. If you have if you have 90%, you will have narrow confidence interval, right? If you have in between, that is 95%, so it is larger than 90%, but it is narrower than 99%. So is the important understanding that you should know. If I increase the alpha value, I will have smaller CI. If I decrease the alpha value, I will have larger CI. So this concept will be sometimes asked in the assessment. So it will not require you any calculation, but if you need to understand, if I decrease the alpha value, what happened to my CI? So that is what we call concept equation. So please understand that. Okay. Now let's move because we have more things to cover. Okay. So now when we talk about confidence interval, other than the confidence level, other than the alpha value, other than the critical value, what happens is that in what we call confidence interval, it involves what we call margin of error. Okay, so what is the margin of error? Okay, so if this is your point of estimation, okay, and we know that we need to find the value that will be the boundary of our point, so that will be lower confidence limit. So lower confidence limit, and this is upper confidence limit. And you know that this is the point in the middle. Okay, so what happened in between the middle point? Okay, in between the middle point to the value of our lower and upper is what we call the margin of error. Okay, margin of error. Okay, so please understand that, because if we are talking about mean, the margin of error would be different from the margin of error of the proportion. But somehow this is how we call as the margin of error. Okay, so for your friend who just joined the class, so please fill in the what we call attendance that I've given you using the link. Okay, now let's look at the first what we call statistical inference that we are going to understand. The first one is the confidence interval for the population mean. Okay, why population mean? Because using our sample, we wish to make inference for our population means. That's why our topic is confidence interval estimate for population mean. Now, if you look at this particular diagram, so you can have that diagram on page 3.8, figure 3.8 on page 80. Okay. Now, let's say we are talking about the mean just now. Okay, this is my X bar. Okay, and if I'm talking about my X bar, okay, my X bar can be estimated. What will be the formula for my what we call confidence interval? So X bar plus minus Z alpha over 2 multiply with variance divided by square root of sample. Okay, so here if you are talking about this middle point to your lower confidence limit, so this one is the margin of error for X bar minus Z alpha over 2 multiply with sigma over square root of n. And here, okay, here is another margin of error that will be X bar plus Z alpha over 2 sigma over square root of n. But now class, bear in mind, okay, somehow or other in your experiment, you will require only small sample. Okay, when we say small, Okay, n will be less than 30 is considered small sample. Means that if my n is 29, I have small sample. Okay, now what if I have a small sample less than 30? So look here. This is what happens if you have n smaller than 30. Your x margin of error will be using P alpha over 2V. Okay, so if you look at your what we call normal table, if you look at your table of normal, if I'm not mistaken, the third one is your T distribution. Sometimes we call it as student T distribution. Okay, this distribution is still normal, but then it follow the understanding that your sample will be less than 30. So what happens if you have that? Your normal distribution will be following T, whereby you will have the parameter involved in your T distribution will be P alpha over 2 V, whereby the V is n minus 1. Okay, so that will be your what we call okay. Now, another thing of the confidence interval for the population mean that would be the condition of your variance. Okay, this is your population variance. You will have two conditions. If your population variance is known, then your formula for confidence interval for your mean is this one. If you do not know what is your population variance, then you have two options. The first option is for n is greater than or equal to 30 or n is less than 30. Okay, so the one that is z alpha over 2 is what we call as our critical value. And x bar is our sample mean. And the thing inside this bracket is what we call standard error of the sample mean. Okay, so let's say we are going to use this particular what we call guideline to find what will be your confidence interval for the population. Let's see few examples. Okay, so this one would be something like in your textbook. Okay, let's move to the first example, example 3.1. Okay, now I realized when I see the way you do your tutorial class, before I can go through to the example 3.1, I realize some of you make a habit of doing a solution without putting the element of the initial process of your solution. For example, if you are talking about the finding the probability for standard normal, so moving from x, okay, from x normal with mean mu and variance sigma square becomes standard normal, okay, standard normal. So it becomes z normal, mean 0 and 1. So sometimes you forget the things that you need to write down. What is your x random variable? What is x? How does your x distributed following the normal? What will be the parameter, the mean? What will be the parameter for the variance? So please, if you need to note down, write down everything as simple way. Just follow the way your textbook do the solution. Okay, systematically. Don't just suddenly you come up with the PZ without showing what would be the PX initially. Okay, so these would be the things that most of the students do. Okay, so and this is not really good because you are going to miss out some of the things that will be given marks. Mark is not is okay, but your understanding is what more important in that. Huh? So let's say we do the first example. Okay, a random sample of size n 20 students is drawn from population of interest with known standard deviation. Now, in statistics, every single word or every single sentence give significant meaning. Because why? You need to understand what does that figure means to the question. For example, for the first sentence, a random sample of n 20, then we know our n is equal to 20. It's drawn from population of interest with known standard deviation. Known standard deviation. So it should come into your mind that, okay, for this question, sigma is known. If sigma is known, then I need to use this particular formula. Okay. Second sentence. Based on sample data, it is found that the mean weight in kg is 64. Okay. Second, x bar is equal to 64.3 kg. Construct and interpret 95%. Ci equal to 95%. Okay. For the population mean, so understand the question. Construct and interpret 95% Ci for the population mean. This is what we are looking for. What is the population mean? By using the sample that you have drawn. Okay. What is the known sigma? The known sigma is 15 kg. So these are all the information given in your questions. So we know that, okay. So if you follow your what we call your textbook, we begin with the mu. What is mu? Mu equal to population mean weight. Okay, mean weight of all students. Okay, so here we know that x is okay. Then we know that we are going to follow x bar plus minus z alpha over 2, and we have known sigma, then sigma over square root of n. Okay, so what is your z alpha over 2? Given the alpha is 5%, so it will be alpha over 2 is equal to 0.05 divided by 2. It will be 0.025. So 0.025 z alpha over 2, or you can say z 0.05 is what? 0.05 is 1.6449. Okay, so the x bar is 64.3 plus minus 1.6449. The sigma is 15 divided by square root of n, square root of 20. Now class, since we know the what we call the condition, automatically you can apply which formula that need to be applied. Now, if you look at your answer in your textbook, you will get this. Let's say I would always do this way. Okay, 64.3 plus minus the margin of error is 6.57. So you will get your value is 57.73 until 70.87. Okay, so if I draw the interval, the x bar is somewhere here, that is 64.3. Okay, and you have the interval, the lower limit, the lower confidence limit is 57.73, and the upper limit is 70.87. Now, what we understand from this class, remember, you are talking about the inference for population mean. We believe that, how many percent do we believe? We believe 95% that our X bar will be between, okay, our mu, okay, our mu will be within this interval. It could be here, it could be here, it could be here, it could be here, or it could be here. So we don't know which one, okay? But somehow we know that our population mean is between this particular interval here. So how can we, how can we, what we call interpret? So we can interpret that we are 95% confident, okay, that the mean weight of all students is between 57.73 and kg and 70.87 kg. Now class, if you understand, look at the way we do the conclusion. We are 95% confident that the mean weight of all students. So this underlined in green is the one that we are talking about, the mu. So this is how we make inference of our mu using our x. So I hope you can you have the immediate, you have the understanding of, okay, fine. I have my x bar. By using my x bar, I can make inference for my population mean, that is mu. So how I can do that? If I'm talking about confidence interval, so this is how we can do the what we call estimation of our mean. Okay, class? Okay, class? So far, okay?
Okay, okay.
Doctor, can I ask a question?
Okay. Yes.
Can you go scroll it up a bit? Shouldn't the value of Z alpha over 2 equals to 0.025 instead of 0.05 for alpha over 2?
Yes. Alpha is 0.05, right?
Yeah.
Okay. Because we are talking about the lower lower tail here and upper tail here. So this will be divided by 2. Did I something wrong or what?
No, yeah, because I was looking at the Z alpha over 2 equals to Z 0.05. So I was saying, like, shouldn't it be 0.025?
Okay, 0.025. Okay, thank you. 0.025, it will be in 1.96. Okay, thank you. Thank you very much. Okay, so let me, next time if I make mistake, just interrupt. Okay, I do appreciate that. So here correction, so 0.025. Okay, mistake here. So it will be 0.025. That will be 1.96. So this one is 1.96. I believe my calculation is correct. Just this one, 96. Okay. 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 Thank you for correcting me. Any other things that you need to ask?
No, doctor, thank you.
Okay. If no, okay. Thank you. So very quick. It's 9:10. So very quick for example 3.2. So if I were to okay, so let's say a UNIMAP researcher, because why I need to repeat again the questions as if you don't know anything. So how we begin our solution, okay? So a UNIMAP researcher conduct a survey to determine mean waiting time for a treatment at emergency room from several government hospitals. From a random sample of 30 emergency room means that this emergency room come from 30 hospitals. Okay, so it is found that the mean waiting time, so the X bar is equal to 174.3 minutes. Okay, with standard deviation now. What does the standard deviation mean? Does the standard deviation belong to the population or the sample? Read the question carefully. It is found that the sample mean waiting time is 174.3 with standard deviation. So now we know that the standard deviation given to you is S. That is equal to 40.3 minutes. Okay, calculate the point estimate and interval estimate for population mean waiting time with 99% confidence level. Okay, interpret the interval. So what would be the point estimate? Point estimate would be, we believe the mu is equal to 174.3. Okay. Now, what is this confidence interval? What is the interval estimate? Now, the interval estimate is X bar plus minus. Now, what is your N? N is 30. So, fulfill the condition for N30, and sigma is unknown, N30. So, we know we can use our approximation using our S. So, Z alpha over 2 S divided by square root of N. Okay, so for alpha equal to 0.01 divided by 2, it will be 0.005, right? So 0.05, it will be 0.005. Sometimes okay, 1%. Okay, divided by 2, 0.005, right? 0.005. Okay, equal to 2.57. What is that? 58, 8 too small. Okay, 5758, right? Okay, so put everything together. So you have 174.3 plus minus the alpha over 2. The critical value is 2.5758 multiply with 40 divided by square root of 30. So if I put it with the margin of error, 174.3 plus minus, it would be it would be 18.95. Okay, so what would be the interval? So the interval would be between 155.35 until 193.25. Okay, so if I withdraw again, so let's say this is 155.35. This is your point estimate, 174.3, and this is your upper limit, 193.25. So we believe our mu, okay, our mu will be somewhere from here until here. So this is our statistical inference for our population mean. So how do we interpret this? We are 99% confident that what? So we are talking about the mean of our I just follow the textbook easy for me because faster. Okay, so confident that the mean waiting time okay, for a treatment at emergency room is between all these mark class. So should put in sufficient way between 155.35 minutes and 193.25 minutes. Okay, so that's how we do it. Okay, if you don't have an equation, let us look at the example that we have, that what we call the exercise. So we have exercise 3.1. So we have two questions, and we have under 3.1 number 2. So let's say I choose number 2 because it is a bit different, because you are not given the value of your x bar, the standard deviation or the variance. Okay, so this one I want you to try. Okay, so let's look at the second question. Okay. Now, score in EQT 203 subject for a random sample of each student in a class of 150 students are given by. So please understand the given sentence. You are talking about a course of EQT 203. The total population is 150 because you are talking about a class of 150 students. So this is your population. Now, since your population is 150, okay, your lecturer wants you to find it. Okay, I give you 10 minutes. Find the CI. Okay, so you are using your each students as your sample. So your n is equal to 8. Okay, and this from 8 students, you got their score. Okay, so you need to calculate the mean scores and the standard deviation. So how? So x bar would be 70 plus 72 plus 65 plus dot until 78 divided by 8 or 150 class, divide by 8 or 150 plus,
8.
huh?
8.
8, because we are talking about sample, right? We are talking about x bar. So your x bar is given by 73. Okay. Now, how to find your variance or standard deviation? You can use your Excel. So, but if you are talking about how we calculate it manually, so your S squared would be 70 minus 73 squared plus second number 72 minus 73 squared plus until the last number is 78 minus 73 squared. Divide by n minus 1 is 8 minus 1. So your s squared would be here, let's say I put it as s. Let's say you got the answer. So S, after calculating, you get 5.1. Okay. So you got your X bar, you got your S standard deviation. Now, my next question. Is sigma known or unknown? Known or unknown? Class. Class. You know that you're going to use this formula, and you need to know sigma known or unknown. Class.
Unknown.
Unknown. Why?
There is no population standard deviation.
Okay, because we don't know what is the standard deviation of our 150 students. Since we don't have the value given, so we are going to assume that our sigma is unknown. If it is unknown, okay, should we use Z standard, what we call the critical value, Z alpha over 2 or T T alpha over 2, B. Which one? Z or T? Z or T class? Class? Sigma is unknown. Okay, so there will be second condition that you need to know whether your n is greater than or equal to 30 or n greater than or equal to 30 or n less than 30. So which one class? Definitely, since we know that we are talking about samples of 8, so we are going to use this. Okay, so we continue. So 1 Roman, X bar is 73, S is 5.15. Construct 90%. Second, 90% CI. So 90% CI, alpha is equal to 0.10. So alpha over 2 will be 0.05. So Z 0.05 is given by 1.6449. Right. So we know that X bar is, let's say, because I use my space, so a lot. So let's put it this way. So X bar is 73 plus minus 1.6449 multiply with our T alpha over 2. So let's say T 0. Sorry, I myself make mistake there. You know that we are referring to our T. Okay, so let's say I put it in here. So T 0.05, and then the V is n minus 1 is 8 minus 1 is 7. What is our critical value? So let's look our table. T 0.0, what's this now? 0.05. Okay, 0.05, 1, and the V minus 1 is 7. So your critical value is 1.8946. Okay, clear everyone, yeah? So 1.8946 using the T distribution. So we have 1.8946. Okay, so continue. You have 73 plus minus 1.8946 multiply with S 5.15 divided by square root of 8. So you have 73 plus minus 3.45. So you will have your CI is between 69.55 until 76.45. Okay, so how do we interpret this? So we are 90% confident that the mean score of all students of EQT 203 is between 69.55 and 76.4. Okay, so that would be for the first for the second one. Okay, the third one, construct a 95% confident interval estimate for mean score of all students. So now alpha is 0.05. Divide by 2, you will get 0.05. Right, 0.025. So T 0.0257. Check your T distribution. 0.025 tadi kan? 0.0257, you will get 2.3646. 2.3646. 2.3646. Okay, so calculate. So you have 73 plus minus 2.3646 multiplied with 5.15 divided by square root of 8. Okay, what do you get there? 2.3646 multiplied with 5.15 divided by square root of 8. 4.31. Am I correct? 73 plus minus 4.31. So now you can see, class, okay, when you are talking about 90%, the margin of error is small. When you talk about the 95%, okay, 95% means that the larger the interval, you are talking about the larger margin of error. Okay, so calculate, then you will get, right, sorry, I continue here because limited space, 73 point minus 4.31, so you will get 68.96 until 73 plus 4, 77.31. Okay, so we are 95% confident that the mean score of all students of EQT 203 is between 68.969 and 77.31. Okay, now compare and make conclusion from your answer in 2 and 3. Okay, so how do you compare? You will need to compare in terms of the interval, the interval value. Okay, so how do you say that? If you have larger confidence level, you will have larger confidence interval. If you have smaller confidence level, you will have smaller confidence interval. If you have avoid mistake. Okay, let us look here. If you have, for example, this one, if you have smaller confidence level, you will have smaller confidence interval. If you have larger confidence level, you will have larger confidence interval. Okay, so discuss using that particular trick for that one. Okay. Okay. Done with that. Any question, class? Okay, we have another 30 minutes. So I think I'll just continue with the second statistical inference for our population, and that will involve the population proportion. Okay, class? Is everyone okay?
Okay,
Let
doctor.
me check
Okay,
how
Doctor.
many of you are inside. Okay, thank you. How many of you are inside my class? 38, so sad. What happened to you, to the rest of your friends? Do you know what happened to them, class?
No idea.
Imagine if you no idea. Sometimes you know what I sometimes feel distracted. Sometimes I don't want to see how many of you are inside because if I can see the number, I lose my mood. Because I don't know, it should be something that you as a you know no longer kid. You should manage your time wisely. It's okay lah. I cannot force everyone to follow what I following my thoughts. Okay, how can we find the confidence interval for population proportion? Okay, if you look at your textbook on page 82, okay, we are going to stop on page 82. Okay, so how can we find the confidence interval for the proportion? Now, for the proportion, what you will have for proportion, you will have your p hat, you will have your critical value. So this is your critical value. So this is your proportion, sample proportion. Okay, and this is your what we call if we have mean just now we call it as sample error. Okay, so here we don't know what's the name, but this one is the proportion for our sample. Now, what is p hat? Okay, how do we find our p hat? Okay, if just now we are talking about mean, we know that we add all the value for our x, divide by the number of samples, then we get the mean. What about proportion? Okay, sometimes when we dealing with large number of samples, okay, there will be time where we are not interested on the mean. Okay, for example, if I'm talking about your population, okay, we are no longer talk about the measurement that we measure from our sample. Okay, instead we would like to see how much of the composition of your population is the one that we are talking about in terms of proportion. Okay, so if we are talking about proportion, half of the proportion, so we are talking about half of your sample. So this kind of half or whatsoever things is what we call as p hat. And this comes from the x that you define. Okay, so what is x? The number of unit with characteristic of interest in the sample. Okay, so what is x usually will be defined in your question. So look at what is defined by x given in your question. And this x will be divided by the number of samples. So that's how we find our p hat. Okay. And for the what we call the margin of error, so this will give you the margin of error. Let's say very quick look at the first example, then we look at the exercise 3.2. Let P the proportion of all students with limited amount of time for self-learning and P hat the corresponding sample proportion. Okay, sample of n 1,500 students, so you have n 1,500 are randomly selected, and it is found that 600 of the students agreed that they have limited amount of time for self-learning. So this is your hint for your x. Given your sample size is 1,500, okay, it is found that 600. So this is what we are referring to x. So p hat, okay, p hat is equal to x over n. What is my x? Student who agreed. X will be student who agreed that they have limited time for self-learning. Okay, so how many of them? 600 divided by 1,500. And you will get your x and your p hat as 0.4. Okay, so we know that we are talking about 0.4 of our 100% what we call population or sample. Okay, now you need to find the 95% confidence level, confidence interval. So alpha is 0.05 divided by 2. So unlike mean, population mean, for proportion, this will be the only formula that you need to understand. Okay, so there would be no condition for your n or whatsoever because we know that this sample size is very big. Okay, for alpha over 2, 0.05 divided by 2, you will get 0.025. So look for z 0.025. Okay, 0.025, you will get 1.96. So p hat is 0.4 plus minus 1.96 multiply with square root p hat, that will be 0.4 multiply with 1 minus p hat, that will be 0.6 divided by 1,500. Square root or not? 1,500. Okay, so you will get 0.4 plus minus square root 0.4 multiply 0.6 divided by 0.001. 0.01. You get 0.01. Okay, so if you take 0.013, okay, so let's say 0.4 minus 0.0126, okay, so if you get 0.4 minus 0, okay, so let's take to the decimal point, so you will get 0.38 somewhere here, 0.4 minus 1. Okay, 0.387. Let's say we take this decimal point. So you will get 0.413. Okay, so how do we interpret this? We are 95% confident that the proportion of all students who have limited amount of time for self-learning is between, you can talk using the decimal point or the percentage. Let's say we follow the percentage. So you will get 38% and 42%. Okay, 41%, not 42. Okay, 41. Okay, that's how we do the proportion. So last but not least, before we stop, let's see one example, one exercise. Okay. Now, we have two questions under the exercise. Let's say we choose this one. Okay. The first question you try. Now, Hassan and Hizamiyani wedding ceremony will be held at KLCC Convention Center soon. A survey is carried out to estimate the proportion of people who will be attended the ceremony based on a sample of 250 invitations. So the whole sample is 250. Okay, from this 250, your X is equal to 180. So those we act is those who return the card and agree to attend the ceremony. So this will be return the card and agree to attend the ceremony. Construct 90%. Okay, so P hat will be equal to 180 divided by 250. So you will get 180 divided by 250. You will get 0.72. Okay, alpha over 2 will be 0.10 divided by 2 is 0.05. So Z 0.05 is equal to what? 0.05. 0.05 is 1.6449. Okay, so P hat would be 0.72 plus minus 1.6449 multiply with 0.72. 1 minus 0.72, you will get 0.28 divided by the sample is 250. Okay, so you will get 0.72 plus minus. Let me count for a while. Okay, square root 0.72. Okay, divided by 250. Multiply with 0.6449. So you will get 0.047. Let's say 3 decimal point. Okay, so for 3 decimal point, 0.72 minus 0.047. So you will get 0.673. And 0.72 plus 0.047, you will get 0.767. Okay, 77. Okay, almost the same. So how can you interpret? So we are 95% confident that, I think I should write this. We are 90% confident that the proportion of all invitation, we are 90% confident that the proportion of all invitation agree to attend the ceremony is between 67% and 77%. Okay, that's how we solve the proportion for the population. Okay, so this is our what we call our statistical inference. Okay, so this is our statistical inference for our P, that is population proportion. Okay, and to get this population proportion, we are making inference using your sample proportion. Okay, class, any question before we start? Class?
No.
Okay. If no question, let's stop the recording first.